Hello, my Math 3 scholars. Today we're going to learn how to graph piecewise functions, okay? We're going to learn how to graph piecewise functions. Okay, a piecewise function is basically, and we had one of these a few weeks ago in class, and I said we're going to look at these more. But a piecewise function is basically a function that when you graph it, it's in pieces on the graph, okay? It's in pieces on the graph. In other words, it might look something like, let me show you this real quick. It might look something like this, okay? So we've got an open circle here, and it goes this way, and then we've got a closed circle here, and it goes this way. Or down here, we got an open circle, and it goes this way, and a closed circle, and it goes that way, okay? So a piecewise function are basically maybe multiple functions pieced together on one graph to create what we call a piecewise function, okay? So we're going to have to look at these based on the information we're given. So let's start with number one here. F of x equals 2x plus 3 when x is greater than or equal to negative 2. And it equals negative x plus 2 if I'm filling in a number that's less than negative 2. So this information that they give you right here, this is very important, because this bases where you fill in your numbers at, okay? So for instance, if I want to do a table of values for x is greater than or equal to negative 2, then that means I'm going to choose greater than or equal to negative 2 would be numbers like negative 2, negative 1, and 0. So I'm going to choose those numbers to fill in, okay? That means I'm using, if it's numbers greater than or equal to negative 2, then I'm going to ignore this bottom equation, and I'm going to use this 2x plus 3 because that's where x is greater than or equal to negative 2, okay? So I'm filling in negative 2. That's 2 times negative 2 plus 3. Okay, that's negative 4 plus 3, which is negative 1. So that's the point negative 2, negative 1. Then if I fill in negative 1, that'd be 2 times negative 1 plus 3. So that's going to be the point negative 1, comma, let's figure this out. 2 times negative 1 is negative 2, and negative 2 plus 3 is going to be 1. So that's the point negative 1, 1. Then, if I fill in 0, 2 times 0 plus 3. Okay, I'm filling in 0. 0 times 2 is 0, plus 3 is 3. So I get that point. Okay, now, if I consider x less than negative 2, so numbers less than negative 2, that would be negative 2, negative 3, negative 4. And you always want to fill in, okay? You always want to fill in both of your negative 2's into both of your equations. Whatever this number is here that you're revolving around, that you're looking at, you want to use it in both of them, okay? And I'll explain a little bit more why. Then, now I have chosen these for you and shown you what to choose. But then you want to choose the numbers that are less than that. So less than negative 2 are negative 3 and negative 4. Okay, so now I'm going to fill in negative 2 plus 2, because you've still got a negative in front of that x, so you have to use it. Negative 3 plus 2, and negative 4 plus 2. Okay, that's going to be negative 2, comma, okay? Double negatives make that positive 2. And 2 plus 2 is 4. Double negatives make that a positive 3, and 3 plus 2 is 5. So at negative 3, we get 5. Double negatives make that a positive 4, and 4 plus 2 is 6. So at negative 4, we get 6. Now, everything that we're doing is around this negative 2. This x is greater than or equal to negative 2, and x is less than a negative 2. So I'm going to come over here, and I'm going to make that line down through here to show you where negative 2 is at. So all of our function here revolves around this line right here. So that means we're going to have something going on this side of the line, on the right, and we're going to have something going on the left side, okay? Now, I'm going to start with x greater than or equal to negative 2. Since that's an equal to, that means I'm going to have a filled-in circle where negative 2 is at. So negative 2 is negative 1. So negative 2, negative 1, that's going to be a filled-in circle right there. Then negative 1, 1. and then 0, 1, 2, 3. Now you can tell this is a linear equation, and you can tell it's rising 2 and running 1. Up 2 over 1. So if you want another point, up 2 over 1. Up 2 over 1. So this side is doing this. Okay? Now let's talk about the other side. This time, since there's no equal to here, it's going to be an open circle. Okay? Where negative 2 is at. So negative 2, 4, negative 2, positive 4 is going to be an open circle. Then negative 3, 5, negative 3, 5, negative 4, 6. Okay, now again, this is a linear equation, and so you can tell this is going up 1 over 1, up 1 over 1, up 1 over 1. So this time we have a graph that looks like that. Now, what this means when we talk about the piecewise function, if it asks you, okay, what is f of negative 2? How would you evaluate f of negative 2? Well, since this is an open circle up here, that means it doesn't equal that value. Since this is a closed circle down here, it does equal that value. So what is my value down here for y when x is negative 2? Well, it is negative 1. So f of negative 2 is negative 1. And that's how you would come up with that, okay? So that's why we have to do the filled in circle and the open circle. Let me do another example for you. Okay, let's look at this one. F of x equals 2/3 x if x is greater than or equal to 3, and f of x equals 3 if x is less than 3. So this time, everything revolves around x being 3. So let's go ahead and mark that. So my x is 3. This is going to be my line this time. Okay, that's my line. Now, that means something's going to be going on the right side of this line, and there's going to be a function on the left side of this line. Okay? So let's fill in some numbers and see what we get. Now, you'll notice I put in 3. You always put in your 3. Okay? Or whatever this number is here, you always put it. And you can see I put it there too. Now, greater than or equal to 3. Normally, I would choose 3, 4, 5. But this time, I chose 3, 6, and 9 because I want this 3 to cancel out and make nice integer numbers, okay? So 2/3 times 3, 2/3 times 6, and 2/3 times 9. Okay, so first I'm going to fill in 3. 2 times 3 is 6, and 6 divided by 3 is 2. 2 times 6 is 12, and 12 divided by 3 is 4. So we get 6, 4 there. 2 times 9 is 18, and 18 divided by 3 is 6. So this is the 0.96. Okay, now if I go over here, if I put in 3 for x, there is no x. So it doesn't matter what you put in for 3, it's always going to be 3. You're always going to get 3. So at 3, it's 3. At 2, it's 3. And at 1, it's 3. Because there's no x for you to fill in. Okay? So let's graph this and see what it looks like. So x greater than or equal to 3, that's going to be a filled in circle. So at 3, 2. So I'm going to go to 3, 2, and I'm going to have a closed circle there. Then 6, 4. Here's 6. 1, 2, 3, 4. And then you can tell that 9, 6 is going to be somewhere out here. Okay, I don't have room. I didn't have that on my graph. So our graph is going to look something like that on that side. Okay, now let's go to the other side. For x is less than 3, that's going to be an open circle at 3. So I'm just going to circle that one because it's the same. Oh, sorry. 3, 3. So 3 and then 1, 2, 3. That's going to be an open circle here. I messed that up. Sorry. 3, 3. And then 2, 3. 1, 3. Hopefully you can see it's just going to continue out through here. Okay. So we're going to have a straight line out through there. Okay, I'd like for you to try the 2 down here, and then in the next video, I will work those and you can check them.